everyone. So today we are going to discuss about the introduction to embedded system. So before discussing about embedded system, first we need to discuss about what is a system എന്താണെന്നുള്ളത് ഏറ്റവും ആദ്യം നമുക്ക് ഡിസ്കസ് ചെയ്യാം. So a system is an arrangement in which all its units assemble and work together according to a set of rules. So it is the definition of a system. System എന്ന് വെച്ച് കഴിഞ്ഞാൽ it is an arrangement in which all unit assemble and work together. So ഒരു system എന്ന് പറയുന്നത് ഒരു arrangement ആണ്. So it is an arrangement and all the units assembled and work together based upon set of rules. ഒരു particular set of rulesന്റെ ബേസിസിൽ അതിനുള്ളിലുള്ള എല്ലാ യൂണിറ്റ്സും ഒരു പർട്ടിക്കുലർ അറേഞ്ച്മെന്റിൽ അത് പാക്ക് ചെയ്തിട്ടായിരിക്കും ആ ഒരു സിസ്റ്റം എന്ന് പറയുന്നത്. And it can also be defined as the way of working, organizing, or doing one or many tasks according to a fixed plan. So it is also can be defined as working, organizing, and doing a particular or more than one task with a fixed plan. For example, ഒരു സിസ്റ്റത്തിന്റെ എക്സാമ്പിൾ ആയിട്ട് വളരെ സിമ്പിൾ ആയിട്ടുള്ള എക്സാമ്പിൾ ആയിട്ട് പറയുന്നത് വാച്ച് ഈസ് എ ടൈം ഡിസ്പ്ലേയിങ് സിസ്റ്റം. ഓക്കെ, സോ എവരിവൺ ഹാസ് എ വാച്ച്, നോട്ട് എ സ്മാർട്ട് വാച്ച്. നോർമൽ വാച്ച് എന്ന് പറയുമ്പോൾ അതിലെന്താണ്, ഇറ്റ് ഡിസ്പ്ലേസ് ദി ടൈം. സോ ഇറ്റ് ആക്ട് ആസ് എ സിസ്റ്റം. ഓക്കെ, സോ ദിസ് ഈസ് കോൾഡ് ആസ് എ സിസ്റ്റം. നെക്സ്റ്റ് വി ആർ ഗോയിങ് an embedded system. So an embedded system എന്ന് പറയുന്നത് ഇറ്റ് ഈസ് എ സിസ്റ്റം ഇൻ വിച്ച് ഈസ് യൂസ്ഡ് ടു പെർഫോം എ സ്പെസിഫിക് ടാസ്ക്. which is used to perform a specific task. So specific task എന്നുള്ള വേർഡ് ഓർത്തു വെക്കുക. So ഒരു embedded system എന്ന് പറയുന്നത് it is a system in which used to perform a specific task. So it is mainly focusing upon a particular task only. Okay, at a time ഒരൊറ്റ ടാസ്ക് മാത്രമേ അത് ചെയ്യുള്ളൂ. So that type of system is called an embedded system. And this embedded system can contain a microcontroller or processor in it. And based upon the instructions given to that controller, it can perform that task. Okay, so that is mean by an embedded system. So that is the definition. So you can look to the another definitions. So embedded means something that is attached to another thing. So something that is attached to another thing. An embedded system can be thought of a computer hardware system having a set. So an embedded system എന്ന് പറയുന്നത് ഒരു സ്പെസിഫിക് ടാസ്ക് പെർഫോം ചെയ്യാൻ വേണ്ടിയിട്ടുള്ള ഒരു സിസ്റ്റത്തിനെയാണ് എംബഡഡ് സിസ്റ്റം എന്ന് പറയുന്നത്. സോ ഇൻ ദാറ്റ് സിസ്റ്റം ഇറ്റ് കൺസിസ്റ്റ് ഓഫ് എ മൈക്രോ കൺട്രോളർ ഓർ പ്രോസസർ, സോ ദാറ്റ് in which we can embed that program in it to perform the task. Okay, so an embedded system can be independent system or it can be part of a large system. So it can be act as an independent system and or it can be act as a part of a large system. So large system എന്ന് പറയുമ്പോൾ ഇൻഡസ്ട്രി ലെവലിലൊക്കെ if it is much more complicated system, it's one of the part can be act as an embedded system. So a system consists of a microcontroller or microprocessor. So ഒരു embedded systemത്തിൽ ഒരു microcontroller അല്ലെങ്കിൽ microprocessor based system ആയിരിക്കും. So which is used to perform a specific task. So specific task perform ചെയ്യാൻ with certain instructions embedded into a microcontroller or microprocessor, it will perform a task. So for a simple ആയിട്ടുള്ള ഒരു എക്സാമ്പിൾ നമുക്ക് നോക്കാം. For example, a fire alarm in an embedded system. It will sense only the smoke and work according to that. So all will be familiar with this fire alarm system in most of the buildings. Okay, so education institution അതേപോലെ തന്നെ പല ഷോപ്സുകളിലൊക്കെ നിങ്ങൾ കണ്ടിട്ടുണ്ടാവും ഫയർ അലാം സിസ്റ്റം. So what is the basic principle of a fire alarm system? So the basic function is that there will be a sensor. So that sensor will detect a smoke or temperature. So after a particular threshold value that's set on that sensor, it will inform the microprocessor or the controller embedded in a system to perform the task. എന്ത് ടാസ്ക് ആണ് പെർഫോം ചെയ്യുന്നത്? അലാം. Or to sprinkle the water in that particular floor. So that is the only task that can perform. Fire alarm system. So that is designed for that particular function. ഒരു ഫയർ സംഭവിക്കുമ്പോൾ സ്പ്രെഡ് ആവുമ്പോൾ ചെയ്യേണ്ട ഒരു ടാസ്ക് മാത്രമേ അത് ചെയ്യുന്നുള്ളൂ. So such kind of device are called embedded system. So many examples are there. So it is one of the example, and one more example, as I said, DVD player, washing machine. So such kinds of things are called as embedded system. So if a DVD player is considered, it can only perform what operation? It can read the data in the CD. And for washing machine, if it considered only to perform washing operation only. Okay, so that are the different. So most of the home appliances are embedded system, but there is some exceptional cases. So chala embedded devices with the technological improvement is changing into a multitask system. So adine namukku fully embedded system ennu visheshipikkan pattilla. ഒരു OS based systems ഒക്കെ ആൻഡ്രോയിഡ് OS based ടെലിവിഷൻസും കാര്യങ്ങളൊക്കെ ഇപ്പൊ നിലവിൽ വരുന്നുണ്ട്. പല ഡിവൈസുകൾക്കും പല മൾട്ടി ടാസ്ക് ഓപ്പറേഷൻസ് പെർഫോം ചെയ്യാൻ പറ്റും. സോ ഫോർ ദാറ്റ് സിസ്റ്റംസ് വി കനോട്ട് കംപ്ലീറ്റ്ലി കോൾ ഇറ്റ് ആസ് എൻ എംബഡഡ് സിസ്റ്റം. സോ നെക്സ്റ്റ് ത്രീ കമ്പോണൻസ് ആണ് പ്രധാനമായിട്ട് എംബഡഡ് സിസ്റ്റം എന്ന് വരുന്നത്. It has a hardware part. And it has an application software, and it has a real-time operating system that supervises the application software and provide mechanism to the processor. Okay, so basically it consists of three components. So it consists of a hardware part. So it will surely have a hardware part. It can be a application program or some codes that is embedded on that controller to perform that task. And in some cases there will also be a real-time operating system. So real-time monitoring system ആയിട്ടുള്ള ഡിവൈസുകൾക്കൊക്കെ ചിലപ്പോൾ real-time operating systems ഉണ്ടായിരിക്കും. For example, a fire alarm system or earthquake monitoring system, and such real-time ആയിട്ട് monitor ചെയ്യുന്ന systems-നൊക്കെ some operating systems will be there. And RTOS, as I said, we will be discussing in later modules, real-time operating system. So based upon the set of rules, the execution of that application will be done. So our operating system based upon some instruction, adile embed ചെയ്തിട്ടുള്ള application program run ചെയ്യും. So normally a small scale embedded system, അതായത് നോർമൽ ജനറൽ ആയിട്ട് വരുന്ന ചില എംബഡഡ് സിസ്റ്റത്തിൽ ബേസ്ഡ് ഡിവൈസുകളിലൊന്നും റിയൽ ടൈം ഓപ്പറേറ്റേഴ്സ് ഉണ്ടാവാറില്ല. മോസ്റ്റ്ലി കോംപ്ലക്സ് ആയിട്ടുള്ള ഡിവൈസുകൾ കൺസിഡർ ചെയ്യുമ്പോഴാണ് അതിൽ റിയൽ ടൈം ഓപ്പറേറ്റിംഗ് സിസ്റ്റം ഉണ്ടാവാറ്. അതിനെപ്പറ്റി ഡീറ്റെയിൽഡ് ആയിട്ട് നമ്മൾ ഇനി നെക്സ്റ്റ് 3rd, 4th മൊഡ്യൂളിലൊക്കെ റിയൽ ടൈം ഓപ്പറേറ്റിംഗ് സിസ്റ്റം പഠിക്കുമ്പോൾ ഡിസ്കസ് ചെയ്യും. സോ we can define embedded system is a microcontroller based system in which software driven and it is a real time control system. So an embedded system is designed to perform a specific job. So example I already പറഞ്ഞ example ആണ് washing machine. It can only wash cloth. Air conditioner is another example. It can only control the temperature in the room in which it is placed. Okay, so these are the few examples, types of examples in our day-to-day life. Will consist of all physical visible things that are used as input and output. So ഒരു ഇൻപുട്ടും അതേപോലെ തന്നെ ഒരു ഔട്ട്പുട്ടും ഒരു എംബഡഡ് സിസ്റ്റത്തിന് മോസ്റ്റ് ഓഫ് ദി എംബഡഡ് സിസ്റ്റത്തിന് ഉണ്ടായിരിക്കും. And it also have a chip, either microprocessor or microcontroller will be embedded, in which there is a code or a software that can, without code or software, that device cannot perform a task. അല്ലെ, ഒരു എംബഡഡ് സിസ്റ്റം ഒരു മൈക്രോകൺട്രോളറും അല്ലെങ്കിൽ ഒരു പ്രൊസസർ ഉണ്ടായ മാത്രം പോരാ. There should be some code or an application that can be run on that real-time operating system. Then only it can perform the given task. So the task can be anything. Okay, the task only avam washing machine ani consider cheyanengil it can only wash clothes. If it consider DVD player, that can perform the DVD reading operation. Or if it consists of fire alarm system, it will monitor the smoke or temperature rise in that particular area, and according to that it will perform the operation. Okay, so these are the as well as introduction of an embedded system. Next, we can explain about the combination, or the embedded system is divided mainly into 3 types, or we can say it as it is a combination of 3 components. First one is hardware part. So there will be hardware part, and there is a software part, and there might be a mechanical component. That is not necessary if there should be a mechanical component such as a moving part, a motor, or such things. So that best example is washing machine. So washing machine consider there is a hardware part, some circuit board, such things, and controller processor, and software part. Software part may be that what program or the code or the application program that can be run on a real-time operating system or such things, and the mechanical components such as a motor that is used to run the mechanical part of that system. Okay, so these are the three main components or the three combinations of an embedded system. So next is the general block diagram representation of a so as I said, block diagram consists of an input port. So through input port, we are giving in the instruction to perform a task. And there is an output port. Output port means the task will be performed, and there is a memory area, and there is a system core which consists of processor or controller and its associated devices. So this is the general functional block diagram of a embedded system. So if you are considering example of a DVD player, so what is the input giving to that DVD player? So now you CD or DVD, insert that play button. So that is the instructions or command that is giving into that system. And what will be the output? Output will be the audio and video form is converted and it is displayed on the television. So there is an output and there is a mechanical part. A CD runs a mechanical motor. So these are the components of a block diagram representation of an embedded system. So next is an important section that we are going to discuss. That is the difference between a general purpose computer and embedded system. So what is mean by embedded system? And we'll discuss it. And what is the difference between a general purpose computer? Okay, so we can discuss one by one. First one is a general purpose computer is a combination of generic hardware and a general purpose operating system for executing variety of application. Okay, so general purpose computer in the it is also a combination of a hardware and consists general purpose operating system. So what is meant by general purpose operating system? That is the operating system that we are commonly used in our computers, such as Linux based operating system, Windows XP, Windows 10. Okay, such operating system is specifically based to perform many tasks. Our operating system based system ഒരു particular task മാത്രമല്ല നമുക്ക് ചെയ്യാൻ പറ്റിയ ഒന്നിൽ കൂടുതൽ ടാസ്ക് ചെയ്യാൻ പറ്റും. For example, we can use an application, different type of an application for editing of an image and for recording a video, and such all the process is associated within that operating system, and it is a multifunction. So that is called it as a general purpose operating system. For an embedded system, it is a combination of special purpose hardware only. Okay, what a general purpose computer it consists of a generic hardware. So generic hardware consists of a microprocessor that can perform a variety of operation that is sound enhancing, modulation, such things all. So in embedded system, there is only particular purpose. In the purpose purpose controller or hardware utilize. Okay, because the cost constraint is very much important. Okay, so here it is a combination of special purpose hardware and an embedded OS for executing specific set of application. So a particular hardware focusing upon a specific task, and if necessary, there will be a particular OS. Most probably, real-time operating system will be present to perform that application. Next, operating system based comparison. It consists of general purpose operating system. As I said, it can have a general purpose operating system in Windows 10, 11, Linux, such operating system. It may or may not contain an operating system. So embedded system can have an operating system, real-time operating system, or it may not contain a real-time operating system. Alterations. So applications are altered by the user. So we can, for a general purpose operating system device, we can alter the application, update the application, modify the application, remove the application. Like general purpose operating system we use in application kalayam. we can update, modify, or install any other application. But in embedded systems, we cannot alter by the user. If it is once it is embedded on that controller, that application will be run according to that task only. Okay, we cannot alter unless the programmer during the design procedures only can change the codes according to that. Otherwise, as a commodity, നമുക്ക് ഒരു embedded system അതിന്റെ software proto അല്ലെങ്കിൽ അതിന്റെ ബാക്കി codes കാര്യങ്ങളൊന്നും modify ചെയ്യാൻ പറ്റില്ല. Next key factor is performance is a key factor. So in general purpose computer, we are particularly focusing upon the performance. So ഒരു സിസ്റ്റത്തിന്റെ പെർഫോമൻസ് വളരെ ഇമ്പോർട്ടന്റ് ആണ്, സിൻസ് ഇറ്റ് ഈസ് ഡൂയിങ് എ മൾട്ടിപ്പിൾ ടാസ്ക്. ഒന്നിൽ കൂടുതൽ ടാസ്ക് പെർഫോം ചെയ്യുന്നത് കൊണ്ട് ദ പെർഫോമൻസ് ഈസ് എ കീ ഫാക്ടർ. ബട്ട് ഇൻ കേസ് ഓഫ് എൻ എംബെഡഡ് സിസ്റ്റം ഇറ്റ് ഈസ് എൻ അപ്ലിക്കേഷൻ ഓറിയന്റഡ്, അല്ലെ? ഒരു അപ്ലിക്കേഷന് വേണ്ടി മാത്രമാണ് അത് ചെയ്യുന്നുള്ളൂ. സോ ദി പെർഫോമൻസ് ഈസ് നോട്ട് മച്ച് ദാറ്റ് മച്ച് ഫാക്ടർ. ഫോർ എക്സാമ്പിൾ, ഒരു DVD player can only perform the reading operation from that disk only. So that performance is not much considered there. Next one is power consumption. For a general purpose system, the power consumption is very much high because it consists of general purpose hardware and its associated components that can have more power consumption. Whereas in embedded system, the power consumption will be less, since there is only a particular hardware or controller used to perform a particular operation only. So the components will be less, so the power consumption will also be less. Next, response time. For a general purpose system, the response time is not critical. എന്ന് പറയാൻ കാരണം, if you are performing a particular task, if we want to get an output, but we are not focusing upon the time. But in case of a embedded system consider ചെയ്യുകയാണെങ്കിൽ അതിന്റെ ഒരു എക്സാമ്പിൾ ആയിട്ട് ഫയർ അലാം സിസ്റ്റം തന്നെ കൺസിഡർ ചെയ്യാം. If a smoke or a heat is detected, it should be quickly respond a alarm or quickly response to its authority. Okay, so that should be responsive and it should be fast. So that's why it is critical for some application. എന്ന് പറയാൻ കാരണം, some application അത് critical ആയിരിക്കും, വേറെ മറിച്ച് other some application it should not be critical. So critical അല്ലാത്ത ഒരു application എന്ന് പറയുന്നത് DVD player അല്ലെങ്കിൽ washing machine, that time is not much constrained. Even if we are giving a time, but that much not constrained. But if a fire alarm system or such monitoring system, the time is very much constrained. Next, we are going to discuss about desirable features of an embedded system. So what are the different features of an embedded system എന്നുള്ളതാണ് നെക്സ്റ്റ് നമ്മൾ ഡിസ്കസ് ചെയ്യാൻ പോണത്. ഫസ്റ്റ് വൺ ഈസ് കോംപ്ലക്സ് അൽഗോരിതം. So the operations are performed based upon a microprocessor or microcontroller will have complex algorithms or the codes or the programs that is associated to perform the task. For example, an automobile engine must perform complicated filtering function to optimize the performance of a car while minimizing the fuel injection. So nowadays, most of the devices is turning into smart, and which is based upon a controller and microprocessor. So such cases, the performance should be a key factor, even if the background algorithm or the codes is very much high in size. So even if the complex algorithm, the system should work according to that particular task. Next one is user interface. It should be user friendly. So Microsoft frequently used to control complex interfaces, such as we want to give input to that system in order to perform a task. And the next one is real time. It should be real time to perform a real time operations, and such as alarm system, monitoring system, and safety instructions, such things and all comes to the real time system. For example, printing an operation, it should perform a printing operation within a particular time limit itself. It should not be get delayed. Delay ചെയ്തു കഴിഞ്ഞാൽ എന്താ സംഭവിക്കുക? Efficient. So it should be real time according to the specific task as well as the specific time allotted to it. Next, multi-rate. So what is meant by multi-rate? The operation should be completed within the deadline. So even if the task is given, the task should be completed within deadline. So there should be a multi-rate behavior for that system. Next thing we are used to check is the manufacturing cost. The overall cost should not be very much high, such as if you are designing an embedded system. So it is the design purpose of manufacturing cost. If you are designing an embedded system, the cost for the components, microprocessor, microcontroller should be very much less, so that the overall cost of that system should not exceed the limit. Okay, a particular embedded system a particular limit exceed. So even if that exceed, that embedded system will not will be act as a good commodity for the consumer to purchase. Okay, so that's why the manufacturing cost is very much important. Next is power and energy. Power and energy is also another important thing that should be design purpose. So the power consumption should be very much less and effective, such that it can supply the enough energy to perform only a particular task only. In the task on a perform that task perform power matrame consume. So that are the different functionalities of an embedded system. Next, we are going to discuss about the characteristics of an embedded system. So, characteristics of an embedded system and discuss. So, a characteristics of an embedded system is first one is single function. So, what is meant by single function? So, from the definition itself, we have discussed about an embedded system is a system used to perform a specific task. So, specific task in the value term on a single function. So, it can only perform a specialized operation only. A specialized operation മാത്രമേ അത് perform ചെയ്യുള്ളൂ. Okay, so the example ആയിട്ട് ഒരു pager example ആണ്. So another example is a DVD player, washing machine, and all these such things. So that can only perform a particular task operation only. Next one is tightly constrained. So it should be tightly constrained, and the design metrics such as it is related to the design area. Design area കുറിച്ചിട്ടാണ് ഈ ഒരു characteristics പറയുന്നത്. So cost, size, the cost should not exceed the limit. Size എന്ന് പറയുന്നത് bulky ആവാൻ പാടില്ല. It should be as small. So nowadays most of compact in size, then only it can be used to reallocate to another area. Embedded system maximum compact size ആയിരിക്കണം. So it should be used to reallocate from one area to another area, and power consumption should be less, and the performance should be very high. So that are the different tightly constrained, and it should be a single chip thing, and it should fast enough to process data and should be real time. And if it is a battery life system, it should extend its battery life. So അങ്ങനെ കുറച്ച് കാര്യങ്ങൾ കുറച്ച് പെർഫോമൻസ് പാരാമീറ്റേഴ്സ് അല്ലെങ്കിൽ ഡിസൈൻ പാരാമീറ്റേഴ്സ് ഒക്കെ ഇവിടെ ടൈറ്റ്ലി കൺസിഡർ ചെയ്യാൻ ഫീച്ചേഴ്സിൽ വരുന്നുണ്ട്. So next challenge is reactive and real time. So what do you mean by reactive and real time? So many embedded system must be continually react to the changes in the system environment, and such things and such environment changes should be computed, and the result should not be processed without any delay. Okay, such things are called reactive and real time. For example, a cruise controller, it is based upon the sensors that will maintain a uniform speed and to apply the brake. And another example is a fire alarm system that we discussed earlier. If a particular temperature or a smoke is detected, it should be process the data in that controller or processor, and it should act according to that. Then only it should be a security device. Okay, what if a time delay or any failure in the system? ഒരു ഫയർ അലാം സിസ്റ്റത്തിന്റെ കേസ് നമുക്ക് കൺസിഡർ ചെയ്യാം. അതിൽ തന്നെ any of the code or any area get malfunctioned. So എന്ത് സംഭവിക്കും? The information will not be passed, or it will not process. So the fire alarm should not be done, or the water sprinkling method will not be done. So in that case, it will be a failure, and it will result into the danger for the human life. Okay, so that's why an embedded system that is designed for that kind of purpose should be reactive and responsive, and should be real time. And the next one is microprocessor based system. So what is meant by microprocessor? As we said, it is a embedded system is a device which consists of a microprocessor or a microcontroller. So most of the embedded system should contain a microprocessor or microcontroller. Then only we can call it as an embedded system. ഒരു മൈക്രോപ്രൊസസർ അല്ലെങ്കിൽ പ്രൊസസർ അല്ലെങ്കിൽ മൈക്രോ കൺട്രോളർ ഇല്ലെങ്കിൽ അതിനെ നമുക്ക് എംബഡഡ് സിസ്റ്റം എന്ന് വിശേഷിപ്പിക്കാനാവില്ല. ഫോർ എക്സാമ്പിൾ, ഇവിടെ ഫാൻ നമുക്ക് കൺസിഡർ ചെയ്യാം. Is a fan is an embedded system? No, but there is an exceptional case. Normally, we call a fan is not an embedded system since there is no processor or a controller in it. But nowadays, smart fans are developed, which we can control using our a single remote control, or using mobile phone. We can control the speed of a fan, and there will be a light module. And in that case, the fan will have a processor or controller in it to process the data. Okay, so infrared waves to the process the infrared waves. So in such cases, we cannot say it as a embedded system, but normally we can say a fan is not a embedded system. So if we can say it is an embedded system, that embedded or that system should have a processor or a controller in it, in which there will be a code or an application running on it to perform a particular task. The next one is memory. It should have a memory. Why we need a memory? Then only we can embed a software or a program in that ROM and to perform the operation according to that. So that's why there should be a memory present, and it will be a micro-based system, and it will be reactive. Next one is it should be connected. So what is meant by connected? The embedded system develop it should be connected to its input and output terminals. So if you're considering an example of a DVD player, it should have an input and its output should be connected to a TV, or it's a output media. Then only we can obtain a video or audio representation, audio output. It should be an audio output and it should have a video output. So video should be presented in a screen and audio should be presented in a audio box. Okay, so that is the thing that should be connected. For every embedded system, there should be an input and there should be an output. Next one is hardware and software system. So there should be a software that is embedded into that hardware. That should be flexible. That should be flexible. Flexible means it should have the particular task features. Our code application should have the program to run a particular task, and should be the code size should be less and should be error free, and it should be secure enough. It should not be modified by any other intruders. So that was our different characteristics of an embedded system. Next, we are going to discuss about the applications of an embedded system. So what are the different applications of an embedded system? Discuss. So first one is consumer electronics. So consumer electronics such as cameras, camcorders, so such things are using embedded system. Next one is household appliances. A variety of devices are used in household appliances such as washing machine, refrigerator, DVD player, and such things. Automotive industries. Nowadays, automotive industries is using most of the embedded system. Anti-lock braking system, ABS, engine control device, smart monitoring system, power window, and all the things are using automotive industries. And home automation and security system, air conditioners, sprinklers, fire alarm, security camera systems. Next is telecom area, cellular phones, telephone switches, and computer peripherals. Computer peripherals in the CPU and computer printers, scanners, connected devices. Computer network system, routers, switches, healthcare. Another important area is healthcare, ECG, EEG, and such diagnostic instruments. Next is banking and retail, ATM machine, automatic teller machine, such all things. And 10th one is card readers, barcode, smart card readers. So these are the few examples of a embedded system. Wide variety of applications are used in embedded system. So in application, now define so computer or a mobile phone is an embedded system or not. A mobile phone അല്ലെങ്കിൽ a computer embedded system എന്ന് വിളിക്കാൻ പറ്റുമോ? No, because it can perform a different task. It is a multi-function device, and even if it consists of a processor, controller, and some hardware component, it consists of a general purpose operating system, and it can perform different tasks. So the mobile phone is depending upon or it is not limited to a single task. ഒരു മൊബൈൽ ഫോൺ വിളിക്കാനെക്കാട്ടി ഉപരി different tasks നമുക്ക് perform ചെയ്യാം, such as we can record a video, take a picture. With a different application we can perform different tasks also with the available sensor in it. And similarly for computer also, it is consists of a general purpose operating system, and it can perform different type of operation. So normally we cannot say a computer based system or a mobile phone as a embedded system. Okay, so the so these are the applications of an embedded system. Hope everyone has understand this topic. Thank you.